video, electrical signals, any other measurable quantities whatever you have can be called as a data here. Now the data can be represented in two ways. One is the analog format, another one is the digital format. Analog is something which is continuous, and digital which is discrete, which is ultimately represented in terms of zeros and ones. Now here embedded system with analog data capturing techniques collect data directly from the analog signals. They don't do any conversion, and embedded systems with the digital data collection mechanism converts the analog data or the analog signal into digital data using appropriate analog to digital converter, and ultimately they represent the analog data in the binary equivalent, that is zeros and ones. Yeah, if the data is a digital data, it can be directly captured without any additional interfaces by the digital embedded system. You don't need any conversion. If the data is analog data, then you capture the analog data and then you got to convert it into the digital data. Next, data collected data collected may be stored directly in the system or may be transmitted to other system, or may be processed by the system, or may be deleted instantly after giving a meaningful representation. Now what are you going to do after collecting the data? After collecting the data, now you can store it, or you can transmit the data from one to the other, or you process the data, and after processing the data immediately you can also go for deleting the data after the data is converted into a meaningful representation. Now these actions are purely dependent on the purpose for which the embedded system is designed. So all embedded systems are not going to do all these things. Now it depends on the purpose. Now if embedded system is designed only for collecting the data, it collects the data. If the embedded system is designed for transmitting the data from one to the other through the data communication system, then it transfers. If the embedded system is designed for processing the collected data, it does that. If the embedded system is designed for deleting the data immediately after it is collected and processed and represented into the meaningful representation, it is deleted. So for example, majority of the embedded systems which are used, or the devices which are used in the medical field, they do this. So for example, ECG machine, it's not going to store anything. It captures the data, represents them in a meaningful format representation, and immediately it is represented, the data is deleted. So I'll show you with the example later. Yeah, here is the example. Now embedded system designed for pure measurement application without storage. What they do, they measure, they don't store anything. Immediately after measure, so the data is represented in a certain format that is understandable by the user, and the data is never stored, it is discarded. One such example, the graphical representation of the data, for example, the data from the ECG machine. As the new data arrives, it is not stored, it is just converted into a graphical representation that is understandable by the user, and the data is discarded. Now analog and digital CROs without storage memory, this is what I told. And then the digital camera is the best example for collecting the data, storing, and even also for representing. Now what they do, they capture the image, they store the image, and after storing the image, you can also view the image, and you can even if required convert it from one format to the other format. Now this is the example for the embedded device where the storage is not necessary, and this is the example for the embedded system where the storage is necessary. Now data communication. Now after collecting the data and storing it, and even after some kind of analysis and processing, so there may be a need for you to transfer the data, send the data from one to the other. So now when I'm saying the communication, now it can be a complex satellite communication system to a simple home networking system. So the communication can vary from this to this. Now there's a support satellite communication system, and even they support simple communication within the home network also. And what is the meaning of the data communication? Sharing the data or transferring the data to a system that is located remotely. Now how do you achieve this? There are two ways of doing this. Now wired line medium can be used for transferring the data, or you can also use a wireless medium. And in the olden days, majority of the communication within the embedded system used to happen through the wired line medium, but with the advent of the technology now, and majority of the communication with respect to the embedded systems is happening through wireless medium. Now because through wireless medium you have many advantages, so easy to manage, and it will also make the communication link free from the hassles of the wire bundles. Now data communication, now when I say the wireless communication, now these are all the wireless modules which are available to support the wireless communication within the embedded system. So Bluetooth, I don't have to explain much about the Bluetooth because you already know that and you are already using it. So mobile phones, your smartphones are supporting the Bluetooth facility. Zigbee, similarly, you can use. Again, this is one more wireless module which is used for making the devices with the short range, not with the too much range, short range communication, Wi-Fi, GPRS, and wire line module, something like RS-232 cable, USB. This majority of you have used the USB, TCP/IP. So these are all the best examples for the communication. Now and you can have a look of the diagrams also. This is the serial communication, the keyboard and the mouse which you connect. And certain embedded system, they can also act as the mediator between the sending and the receiving terminals. And being a mediator, what they do data packetizing. So they'll understand in more detail when you study the networking concept, because explaining data packetization will require another 1 hour. Encrypting, decrypting. So these are all the things what that embedded system, which is acting as a mediator between the sending and the receiving terminal, will do. Encrypting the data, decrypting the data. You'll be discussing more on these things in the networking subject, and here I hope it's not required in much detail. That is enough. And these are all few embedded systems, which assist in the data communication. Network hubs, routers, switches. I have shown the pictures here. This is a D-Link switch, and this is the router, and this is the network hub. And network security, monitoring, everything is required. And this is what the Bluetooth, and this is what the Wi-Fi is. Now processing. You understood collecting the data, storing the data, representing it in one format to the other format, and data communication. Now processing. And when I say you can process a video, a voice, image, video, electrical signals, and other measurable quantities. Now what is the meaning of processing? When certain applications demand the signal processing, like speech coding, synthesis, audio video codec, coding and decoding, transmission applications, etc. The data processing is necessary. Now one example I have written here, say speech is getting converted into a text is one example for the data processing, where the speech is getting converted into the text. And similarly, digital hearing aid is the best example for the embedded system, which involves the data processing. Here what digital hearing aid does, it improves the hearing capacity of the hearing impaired person. So that is what it is enhancing the strength of the speech, and making the person who is really hearing impaired to get the clarity in the speech. So this processing, data processing, or enhancing the data. Next is monitoring. Now, as I already told, there are embedded devices which are specialized in monitoring functions only. That means they monitor the variables and they produce the results accordingly in the display devices for the user to go through that data and interpret the variables. Now, and majority of the devices which are used in the medical domain are monitoring devices. So, they are used to determine the state of some variables using input sensor, and they cannot impose control over the variables. That means they cannot change the state of the variable. Only they can monitor the state of the variable. Say, for example, ECG machine monitors the heartbeat of the patient, but it cannot impose control over the heartbeat. What it does, it only monitors. It just observes the variables which are related to this particular thing, but they cannot modify the states of the variable. In other words, it cannot impose control over the heartbeat, but it can monitor the heartbeat of the patient. Now, other examples with monitoring functions are the measurement like digital CRO, now which you have already used. Digital CRO you can use only for observing something, the data, but you cannot control it. You cannot control it. Whatever is there, the same state is displayed in the CRO. And again, the digital multimeters also, logic analyzers, these things. So they just monitor the status of the variable like current, voltage, etc. But they cannot control the variable in turn. They can control the variable in the turn means they cannot change the states of the variables or the values of the variables. Next is this is quite opposite. Control is quite opposite to monitoring. The embedded systems which are designed for monitoring, they only monitor without having the capability to change the states of the variables. But the embedded systems which are designed to control functionalities, impose control over some variable according to the changes in the input variables. Now, a system with control functionality contain both sensor and actuators. A system with monitoring functionality contains only the sensors, but a system embedded system which is designed to control also, so they contain the sensors and the actuators. The sensors are connected to the input port because using the sensors, the sensor sends the data, and via the input port they give it to the embedded system. Embedded system processes it, and the actuators connected to the output ports are controlled according to the changes to the input variables to put an impact on the controlling variable to bring the control variable to a specified range. So, say for example, the ACs, air conditioners, are the best example for this. Now, when the room temperature increases, say from some temperature to the another temperature, then the air conditioner, the sensor senses that, and the actuators immediately will change the settings inside the air conditioner in order to adjust the temperature according to the increase or the decrease in the room temperature. Now that they have the ability to change. So that is what the output. Actuators are connected to the output ports, and sensors are connected to the input port. And later in the next chapter we are going to discuss in much details the sensors and the actuators. So will not spend much time here. I hope you understood this. Now, control, that means they have the ability to change the states of the variables, or change the values of the variables. When I say monitor, they can only monitor without changing the values of the variables. Now, application specific user interfaces. Say embedded systems, user interface. We are focusing only on the UI part. The interface, a graphical user interface through which the user will interact with the system. Buttons, switches, keypads, lights, speakers, display units, etc. are the application specific user interfaces. display units are there. If the system wants to convey something to the user, it conveys through the display panel. So if the system wants to convey something to the user, so it can convey it through the buzzer also by making the beep. So all these things. So mobile phone is the best example for the user specific, application specific user interface. In mobile phone, the user interface is provided through keypad. You can interact with the system through the keypad. So graphical LCD model, through the touch screen also you can interact. So you can interact with the speaker. So when something happens, you can the mobile phone can also alert you. Now the mobile phone interacts with you by vibration alert. There are many things. So these are all the user interface through which the user can interact with the system, or the system can interact with the user. Now if I want to interact, make a call to some person, then what is that I have to do? I have to open my contact list. Now to open the contact list, I should have a button, and when I click on that button, it should open me the contact list, and when the contact list opens, it should allow me to choose to whom I have to call. A list of users will be displayed. I have to scroll up, scroll down, this facility should be there. Now when I get the required user to whom I need to make a call, so it should allow me to click on him. So when I click on him, it should automatically dial to the user, and ringtone, all these things must be dial tone, all these things should be visible. And similarly, when somebody makes a call to me, it's going to the phone will interact with me by making a ringing tone, or by making the vibration. Now and finally, to conclude, these are all the purpose of the embedded system. The purpose of embedded system we discussed. One is storage, and collection, storage, representation, and then data transferring the data from one to the other, processing the data, monitoring the data, controlling the data, and application specific user interfaces. So these are all the purpose of the embedded system. And finally, to conclude this chapter, that is I have completed one chapter in module 3. That is the first chapter in module 3, and there is one more chapter to in this module. Now if I complete the second chapter also, the second chapter is not as small as the first chapter. Second chapter is really big. Now to complete the second chapter, I may require 3 to 4 hours. 4 hours is also, I think, very small. So I think for me to complete the second chapter of module 3, I may require 5 hours. So 5 hours. Now this is what the summary, what we did in today's class. You understood the definition of the embedded system. Prior to the definition of embedded system, you understood what is a system is. System is a collection of interrelated components which work together to achieve a common purpose. And then you understood the definition of the embedded system, that is, it is an electronic or electromechanical system which is designed in order to perform a particular function or a specific task using a combination of hardware and firmware. And later you understood the definition, the IEEE definition of embedded system also. IEEE defined embedded system as a system or a device which is lodged or housed or placed in other larger system in order to control its operation. And later you understood the basic differences between the embedded system and the general computing system, and then the history of the embedded system, and then the classification of the embedded system. Now embedded systems can be classified based on 4 major categories. One was on the generation, other one was the complexity and the performance, one more was on the deterministic behavior of the embedded system, and the fourth one is on the triggering based classification. So but the syllabus, there are only 2 classification, that is generation based and complexity and performance based classification, so that you understood. And later you understood the application areas of the embedded system. So the application area ranges from the simple electronics toys to the more complex embedded systems which are used in the flight and the missile control systems. And later we we ended this chapter by discussing the purpose of the embedded system. So the purpose of the embedded system can be any one of those five purposes what we understood. It may be used in a collection or data storage or representation, or embedded system can be used for data communication, transferring the data from to the one to the other, or it can be used for processing the data, monitoring the data, controlling the data, or it can be used for developing a user specific user interface, application specific user interface, or some combination of these things. So not necessarily the purpose when you're designing an embedded system, the purpose need not be any one among them. So even it can be a combination of these things, one or more combination of these purposes. I hope here we are completing the chapter 1 of module 3. In our next class, we'll start with the chapter 2 of the module 3. So the chapter 2 of the module 3 is on the core components of the embedded system, where we'll be discussing in detail. This is the end of chapter 1 in module 3. So tomorrow I hope I'm going to give you a small quiz on the module 1 and module 2. So just be prepared for these things. Thank you.